Perhaps the first question would be, when was the first discussion about building the Duncan Dam?
Well, I guess the first that I recall was, or when I say I recall, that I heard about was in the 1940s when there was a general proposal put to the International Joint Commission regarding beneficial use of Columbia River waters for the U.S. and Canada. And there's a reference in some correspondence to a date of March of 1944.
Well, why was the Duncan Dam site chosen?
Well, I guess in casting around throughout the Columbia watershed for logical sites, storage sites for storing Columbia water, there was a number of reasonably good sites. The Yarrow site, there were sites in the East Kootenays too, Libby, of course, in the States, and Mica in Canada. And on the tributaries, a logical one was at the Duncan, where the Duncan Dam is now, where the Duncan River could be controlled or stored, the waters from the floods in the spring stored at Duncan.
Were other sites considered within the Lardo Valley?
When you say considered, they would probably other sites would be looked at, and for maybe looked at superficially, and then for obvious reasons would be dropped. Either the site topography might be good, but the storage area or storage volume that you could get would be small, or the Lardo, of course, with its famous fish runs, could not be looked at without thinking about how any fish problems would be handled, and that would discourage doing anything but superficially looking at the Lardo.
Mm-hmm. What was the actual job performed by the Duncan Dam?
It stores the flood waters of the Duncan River.
Is that important for power generation below Nelson, a lot in Canada, on the lower Kootenay?
Gradually, it wasn't terribly important before. It contributed to the construction of the Duncan when it was completed in '67. It began to contribute to power production on the Cominco and West Kootenay power plants along the Kootenay River below Nelson, and it also contributed quite markedly to flood control at Trail. Mm-hmm. And then as the years have gone by, its contribution has increased because of first of all the construction of the Kootenay Canal project, which it helps there, and then in the future, if the Murphy Creek project on the Columbia River near Trail, if that's constructed, the Duncan storage will also be going through generators there and making a contribution. So its contribution was reasonably significant in the old days when it was first finished, and its contribution will be more and more as time goes on.
Mm. Do you know how much water is stored behind the dam offhand?
I'll have to figure it in what the old figures, 1 million acre feet, is it? I can't recall. And I guess nobody talks acre feet anymore anyway. It's all metric units now, yeah.
What's the equivalent? Cubic meters of water?
Cubic meters. Mm-hmm. Mm-hmm.
An American analyst of the Columbia River Treaty, Crutilla, criticized the selection of the Duncan Dam site, saying that it was not the most cost-effective site, and I wondered if you could comment on that.
Yes, I think he's correct in the sense in which he put that criticism, and I think that was on the basis that if it hadn't been first added. Mm-hmm. But the Canadians, in their negotiations with the Americans, were very aggressive about taking advantage of the fact that in Canada we could add storage first before the Americans could add it on any projects in the States, mm-hmm. and that we should get the credits and advantages that accrued from that early added storage. Now, Dr. Curtilla is correct. If you added that storage later, mm-hmm. it wouldn't contribute as much or anything like as much as it was able to contribute as the first added storage. Mm-hmm. As the first added storage, it was reasonably cost effective. If it had come in later, which that's the American argument, of course, if it would come in later, it wouldn't be effective, and the Americans wouldn't have paid as much for it.
Mm-hmm. One thing I wondered in reading that was that I wondered if the choice of the Duncan Dam had to do with the desire to have more storage behind the lower Kootenay River below Nelson, and that Curtilla suggested that the storage could have been built, the same volume of water could have been stored behind a dam on the Columbia River, and I wondered whether there was a specific interest in having a storage dam behind or above the lower Kootenay below Nelson, and that was a specific interest of BC Hydro.
I just don't know. I don't know. I know that the Duncan does contribute by having storage on the Duncan. It contributes to power generation in Canada, which you wouldn't have got to and won't get to any degree with the Arrow. So there's certainly more of an advantage to Canada in having the storage on the Duncan.
Could you describe your role in the construction of the Duncan Dam?
Well, I was managed the actual construction of the dam. I was a senior individual on the project, looking after the construction of the dam. It was a fascinating dam to construct, one of the most difficult dams in the world that had been constructed. The dam some days settled as much as 3 inches in a single day. The foundations were extremely deep. When I say extremely deep, there was no rock foundations. Rock was overlain by thousands of feet of sedimentary materials, sands and gravels, loose sands and gravels, silts, and build a dam on such a foundation was a tremendous challenge.
Was it unusual?
Extremely unusual, one of a kind almost, and various people in Canada, Dr. Hardy of the University of Edmonton in particular, deserve a tremendous deal of credit for tackling a dam, and Montreal Engineering Company, the consultants, and coming up with what proved to be an excellent design in untried territory. The problem with the dam on foundations like that is that the dam has to be able to settle and retain its integrity. Of course, it can't. If you were to build, for example, a concrete dam on such a foundation, the foundation would settle, the concrete would crack. It would be just no good at all. So the design of the dam had to be designed on the basis that it would settle during and after construction. I guess during construction, from the beginning to the end, it settled around 14 feet. The foundations, in other words, went down 14 feet during construction, and yet the dam was able to accommodate all that and remain perfectly sound. It has since settled. This settlement gradually slows up, and the settlement now I think is in the order of 17 feet total, something in that order. And the dam is inspected regularly and with absolutely no signs of distress or problems. The other interesting feature of such a dam is cutting off the seepage under the dam. You can appreciate if you put a dam on rock, fine, you've got a solid rock foundation, the water isn't going to go through it. If you put it on pervious materials like sands and gravels, the water is going to go through it. And how are you going to control that? It's all right to have water seep through it as long as it's controlled and there's no large amount of what we call piping, where the water goes through too quickly, begins to carry particles of dirt with it, and makes a pipe right under the dam, and you have undermines the dam. So to deal with that, the designers did three things. They put, first of all, an upstream blanket on the dam to lengthen the seepage path of the water going under the dam.
Could you explain that a little?
Yeah, the blanket is an earth fill, an impervious material that's placed on the floor of the valley, upstream of the dam, stretching from the core of material that's in the dam, the impervious core in the dam, and going upstream. I can't remember now. I think it was 700 feet, something in that order. Well, that means that any water can't get through the blanket because that's impervious. So it has to go underneath the dam through the pervious layers, and the advantage of the blanket is that it extends the length of seepage path and makes the water lose its head going under the dam, and it becomes safer. Well, that was the one feature that was incorporated in the dam. The second feature was that at the downstream end of the dam, a series of wells were put in, deep wells around 200 feet deep, and I think they're around 3 feet in diameter. And these wells bleed off water coming under the dam harmlessly and don't allow, I guess, not being strictly correct technically here, but don't allow lifting action under the dam, uplift under the dam. The water is bled off from these wells, and you don't have anything trying to lift the dam. The third and very, very successful feature that was incorporated in the dam was a cutoff wall about 80 feet deep and 10 feet wide that was constructed under the core of the dam and went down through pervious layers and tied into a more impervious layer of earth down about 80 feet beneath the dam. And this was very, very effective in cutting off flows through the dam. We put instruments on each side of that core so that after the dam was filled that we could tell what was going on down there. And we found that on the upstream side of the core, the water pressure was equivalent to the full water pressure of the lake. And 10 feet downstream of that, the water pressure had completely disappeared and was the water pressure that was equivalent to the tailwater at the downstream end of the dam. So that 10 feet of core completely cut off the seepage going through the underneath the dam. And what was so interesting about it was built with an entirely new technique. It was a slurry trench cutoff. They're becoming more and more common. But when we built that one in Canada, it was the first that had been constructed in Canada. Some scientists had discovered that bentonite, which is a clay type material, when mixed with water in form of a slurry and put in a trench will hold the walls of the trench up vertically without the walls caving in. Now, if you were to go out at Duncan Dam site and drag line, which we use to drag line to dig the trench, the minute you got down, I don't know, 10 feet or so, the banks would all slough in. So in the old days, what we did there, we built a similar dam to this at the Tertsagi Dam. In the old days, we used to drive steel piling down on each side of the trench, excavate the material between the sheet piling, and brace across from the piling. Very, very laborious, expensive process, a lot of handwork, and just plain expensive and difficult. This system, you start your drag line going, and then as soon as you've got a small hole started, you introduce this bentonite water slurry, and then you keep on digging, and you keep on digging material out, and you keep your slurry bentonite mixture brimming full. And as a result, and for a long time not completely known why, you could dig, and we did, 80 feet deep with absolutely vertical sides with no support apart from the slurry. You don't see your trench. You're never able to, you could send divers into it, but you could never actually see the trench, but of course you know it's there, and you keep it full of slurry. And then you travel across the valley bottom, which was the best part of a half a mile, I guess. Quarter of a mile anyway, I've forgotten the length. And as you travel along, you backfill the trench with an impervious mixture of materials, including some bentonite, and keep traveling. So you're traveling along the valley bottom with a slug of slurry bentonite mixture, and backfilling as you go with an impervious filling in the core, in the trench. So you end up at the other end with impervious, what proved to be exceptionally impervious core, all done very quickly and efficiently, and just simply marvelous. That technique is now being used all over the place. It had been used in Europe a bit. It had been used once or twice in the United States on a small scale. But the time we used it in Canada was we were breaking a lot of new ground. We discovered a lot of new things about slurry trenches there that went into the engineering literature. We had international groups of engineers coming from all over the world to see what we were doing, both in the slurry trench technique and in the construction of our dam to accommodate these huge settlements. People from Europe, Australia, India, New Zealand, Eastern Canada, United States, everywhere, South America, came to visit the dam. It was very a very challenging dam, very successful dam, and of high interest internationally.
You mentioned a dam that you had built before. Where you had to use a piling method? Yes,
the Mission Dam, as it was called, and then the name was changed to Tertsagi Dam.
Can you just spell that out?
Those dams you can find.
Was there any consideration for power generation at the dam?
At Duncan Dam, yes. When I say yes, there are two tunnels that are used for, they were used to divert water around the dam during construction, and they're now used to pass water out of the dam for downstream release of water. And those tunnels, with some work, can be used as intakes to a powerhouse, which would be constructed downstream into the tunnels, and we could produce power there. Unfortunately, your main or your main demand for electricity, of course, is in the winter months. December, January, generally your peak loads are then. And unfortunately, with a storage dam, that's when your head is generally the lowest. You've drawn out water all fall and from the spring flood that you've caught. And by the time the dead of winter comes, your reservoir is way down, and your power producing capability is greatly reduced because of the head going down. So just when you would need the power the most, you're unable to really produce much. Now, that up until recently has been a major stumbling block in developing storage dams for power production. But now with hydro system being so large, any power that you generated at any time of the year can prove to be useful, because you can actually use the power there and hold back at other projects that do fine in the winter. So the situation is changing, and it wouldn't be surprising at all to see powerhouse constructed at dams like the Arrow and Duncan. They won't be have anything like the power producing capabilities of our big dams, but they'd be significant.
And then the electricity wouldn't just be for consumption in the area, but would rather tie into the province-wide grid.
And that would be the big advantage because of the grid now, and because we have some huge reservoirs on the Peace and at Mica. You can just hold back a little bit at those projects and make use of the power from Duncan when it is able to produce, and then when it isn't able to produce, of course, you make it back up from your main projects. That wasn't possible before the Arrow and before the Mica and the Peace projects were built, but now that is possible.
So to produce power there doesn't involve changing the cycle of letting water out of the dam at all?
Not really. Mind you, during construction, I guess there would have to be various accommodations made to flows. I guess we'd have to be passing water over the spillway at Duncan, for example, and not through the tunnels. As maybe we would work off one tunnel, or two of them, work off one tunnel initially and then swing over to the other, this sort of thing.
Why was the dam flooded before all the timber was removed from the area behind the dam?
That was a government decision. I guess there are a variety of political and financial reasons for doing that. But the government of BC took over the management of the reservoirs, both Duncan. They left the Arrow Reservoir with BC Hydro, but they took over the Duncan Reservoir, that part of the Libby Reservoir that's in Canada, and the Peace River Reservoir. And you'd have to ask people in the lands and forests area, I guess, for the various reasons that led to that decision.
In the short term, certainly, it was expedient, I suppose.
It was expedient, and I guess if you've got a lot of money tied up in a project, you would want to make use of the project as quickly as possible. It's just much more economical to do so. There was some pre-logging done. On all the projects, but not as much as could have been done, I guess, with a lot better planning and thought given to it.
Well, a little bit going back to your experiences in building of the dam, perhaps you could describe a little bit more of the process and your involvement. Or did you live in the area?
Oh yes, we lived there. We had a small housing area built for the married staff, and we had bunkhouse set up for the workmen, and their mess hall and all that went with it, shops, and a number of contracts were let to contractors who came in and made use of the bunkhouse facilities and so forth. I can't remember the numbers of people that worked on the project, 500 or 700, I believe, something in that order. Most of whom were from, if not the absolute local area, most of them would be centered from the Castlegar area. They actually learned a lot of them learned their skills and trades on the Duncan and Arrow Dam, and they have traveled around the province on dam construction ever since, often leaving their families in Castlegar area, Nelson and Trail, I guess, Fruitvale, Salmo, Caslow. Yeah, we had a very pleasant time there. Beautiful part of the world, of course, to live during construction. We had a marvelously successful construction program. We completed the work about almost a year early. I think it was 11 months early. And because of that, we were able to sell one full reservoir full of water to the Americans a year that wasn't included in the treaty. And so we got a considerable amount of money for that, I think $6 or $7 million. In addition to that, since we completed the year early, the Americans were obliged to give us flood control money early. There, I think it was $11 or $12 million flood control money was to come. Well, it would have come in any case when we completed the dam, but we got it a year early, which all helped. And then the administrative costs, engineering costs, all the overhead costs, all that sort of stuff was chopped off a year early, and great savings there. So, and the project was built within the original estimates. So putting the whole package together, it was a resounding financial success. And then it was such an interesting challenge, and one thing or another. It was a success as far as I looked at from an engineering point of view, a very notable advance in the engineering art. And I guess best of all, there was no fatalities. There was no workman killed on the job, which again was remarkable for its size and time and numbers of people working on it and whatnot. So practically every measuring stick that we wanted to measure the project by turned out to be a winner.
Who were the major contractors on the job?
Well, the major contractor was the Mannix Construction Company from well, our headquarters are in Calgary, and they are now called LORAM, I think is their name now. And they had a couple of partners. I've forgotten the partners' names. It was a consortium, but the sponsor, as they call it, was the Mannix Company. They did an excellent job. There were also contractors that supplied a lot of the gates, and there were a contractor who was more of a consulting type of assignment, who helped on the slurry trench. Who else? I guess there were others involved in clearing. I believe Farstead, I can't remember the name, but Al Farstead from Creston was a clearing contractor, head of the clearing contractors. And my memory doesn't go back too good. That I can't remember.
The building of the dam brought a lot of infrastructure development into the valley as well.
We tried to help with that. The workmen, and one of the requirements that we have with a large group of workmen, of course, they have to have a recreation hall or something. They're a bit remote there. And we intended to build a recreation hall in the bunkhouse complex. And then Sam Walker, incidentally, was the construction manager who started the job going before I got there. He did a lot of good work with the community, and managed to get a sort of a joint approach where the community would have make some contribution to a recreational hall, but we would build it actually primarily with Hydro's funds, contractors' funds, and then turn it over to the community when we left. And so it was built, the community hall was built near enough for right in the bunkhouse area so the workmen could make use of it. But it was also built so the public could make use of it. And it was a very successful venture. Bowling, well, you may know, we got second-hand bowling alleys from Nelson and moved them up there and installed them. Had a nice hall built, all with a lot of volunteer labor, and Hydro's money and the contractors' money and a bit of the community's money, and community ended up with a dandy community hall. So we helped in that way, I guess. Also with the other thing that was quite successful with the project was the fish handling facility or fish rearing facility that was built on on Meadow Creek there. The dam, of course, cut off fish, various types of fish going into Duncan Lake, and it was one of the miseries that came out of the dam was the fact that it destroyed fish runs going up into the Duncan. And to offset that to as much higher degree as possible, Hydro financed the construction of a spawning grounds on Meadow Creek, which was downstream from the dam, and a lot of new ground was broken there too, and that has proven to be a very successful venture. That spawning ground has had great successes, as you probably know.
Also, that was the first time that hydroelectricity was brought into the area, wasn't it?
Yes, that's right. That's right. The local people had done without electricity before, and they appreciated that. They, needless to say, didn't appreciate having their wonderful way of life disrupted by the construction and all that went with it. But there were some good things came out of that end, including provision of electricity. I enjoyed the meeting a lot of the local people. They're a wonderful, interesting bunch. Of course, there's the Quaker community at Argenta, and some very fine people that have become friends of mine there. I guess Hydro also took part in schooling situation there, building a new school which was necessary for the influx of workers and their families, and that's left behind. I presume has proven to be a good addition to the community. I guess our family just enjoyed the area. We had one observation that's not common, I guess, and you never hear about. When the dam was completed, we'd always tried to swim in Duncan Lake and found it was very, very cold, extremely cold, and actually a good lake for fishing perhaps, but not swimming. And so we quickly gave up swimming. We never went swimming in the lake. And after we finished the dam and the water was filling, the reservoir was filling, and we were actually building the monument on top of the dam, a big rock, which one of the architects considered would be making a good monument. We were putting that in place, and the carpenters that were working on it said to me, "Have you been in swimming?" And I I said, oh, what are you talking about? And they said, well, it's quite warm. I said, don't kid me. I've been in that water. It's not warm at all. And they said, oh, yes, it is. And so I went down, felt the water, and by golly, it was warm. So I scientifically went to and got some thermometers, and I read the temperature of the water at the top of the lake where you would be swimming, and the water was above 70 degrees Fahrenheit. And then I went around to the outlets, which are drawing water off out of the lake at the bottom. And the water coming out of there was somewhere around 49 degrees. So I concluded that the thing was like a big hot water tank. The hot water is on the top. Most of the drawdown, some comes from the spillway, but most comes from below. So you're drawing off cold water, you're leaving the warm water at the top, and so we started swimming in the lake, and I've forgotten how long we were there after that, but we really enjoyed the swimming. Now, I don't know what's going on up there now, but I'm sure people who couldn't put a toe in it before are having a fine time swimming. So this was another, I guess not an important advantage, and for a fisherman maybe not a very important advantage. Certainly for people with families that enjoy picnicking and swimming and that sort of thing, the lake is a lot better now.